Hey, welcome back everybody to part two. Kind of got caught off there. I tend to go on and I was going on for a while. You guys don't know how much I was still writing. Anyway, anyways. So, I'm not sure how much you heard. So, let's just talk about this. So, because when you sub -6 back in and we get a negative number inside the log, this answer would be extraneous. This would be our actual answer. But if you kind of look at it in terms of what the domain on the log is, like if you go back to this one, x plus 1 has to be greater than 0, right? And this one, 2x minus 3, has to be greater than 0. So if we were to solve each one of those inequalities, that would mean for this one, x has to be greater than -1. And in this one, x would have to be greater than, bring the 3 over, divided by 2, 3/2. Now, whichever one is more restrictive, or the larger number, okay, so you would go with whichever one was more restrictive, because 3/2 is bigger than -1. This answer would be more restrictive. So all our answers would have to be greater than 3/2 or 1.5. Okay, and this one was okay with that. Now here we would have x plus 4 has to be greater than 0. X plus 3 would have to be greater than 0. So x would have to be greater than -4. X would have to be greater than -3. More restrictive would be this one. So all of our answers have to be greater than -3. That's why -6 didn't work so well. Okay, so let's take a look at example 3. Okay, first of all, why don't we do our domain right off the bat? Okay, so here x has to be greater than 0. Here x plus 3 has to be greater than 0, so x would have to be greater than -3. And which one's more restrictive? This one. Because basically what I'm saying with that is if we, say, had an answer between -3 and 0, like -2, it would work for this log, but not for that one, and therefore you couldn't have it at all. So that's why we go with basically the higher number. Okay, so looking at this equation now, solve 2 log base 3 of x minus log base 3 of x plus 3 minus 3 equals 0 to 2 decimal places. Okay, that concerns me. 2 decimal places. It's possible that we may end up having to use quadratic formula, but hopefully not. Let's try it out and see. Okay, let's see, we've got that. We do want to combine these log 3's, but there's a 2 in front of this one. So let's use our power rule and bring that 2 back into the exponent. Okay, the other thing is this 3, we need to actually take that to the other side, because when we do combine these two logs, we don't want to have two terms like that term and the 3 on that side. So one term on either side to change it to exponential form. Okay, so these are both base 3 and they're being subtracted, so we can write that as dividing within one logarithm. And there we go. Get rid of the log. And we have x squared over x plus 3 equals 3 cubed, which is going to be 27. Okay. Now, let's see, we don't want a fraction on the left-hand side, so we are going to multiply both sides by x plus 3. And we would get x squared equals 27x plus 81, if you multiply that through. Let's bring that all to one side. We now have our quadratic equation. There we go. Let's see. So, there, I lost my x. Multiply to -81, add to -27. I don't know if that's going to work out. And given that they said 2 decimal places, I think we're just going to jump into quadratic formula. -b plus or minus the root of b squared minus 4ac all over 2a. Okay, so our a, I'll just write this down. A is the coefficient in front of x squared, that's 1. Our b is the coefficient in front of x, which is -27. And our c value is the constant term, which is -81. Okay, so let's put that in. -27 plus or minus the root of -27 squared minus 4 times a times c all over top of 2 times a. Okay, so let's simplify that. 27 plus or minus, and we'll get a number for what's underneath that square root, okay? So let's do that. Okay, so you would have gotten 1053. Now, we want to get our 2 answers, so best way to do that is to type what's remaining all into the calculator. So let's bring up our calculator and do that. Okay, so we have this, and we're going to go bracket 27. Gotta have brackets around the numerator, okay? Otherwise we're only dividing by the 1053 square root. Okay, so plus square root. We're going to do the plus, and then I'll show you how to get the negative afterwards. Okay, oops, missed a 0. 1000, oh, missed the 0 in the wrong place here. There we go. Okay, I'm having fun with this. I don't know about you. Not. Okay, I'm going to get that typed in. And then okay, managed to get that typed in. All right, so we have that, and then we hit enter, and we get that as an answer. So notice where my brackets are. Make sure you have that same thing going on. Or if you have the newer calculators that don't do the brackets, you're in math print notation, then just make sure that you start the divide outside, or end your bracket outside of that square root, okay? So we have 29.72. We're going to write that one down in a minute. But the other one, here's a good way to get it. Second, enter, and that brings up what you just typed in. In fact, you can go back 3 or 4 steps by just keep going second enter. Okay, so we're going to go back and change our plus sign to minus sign, and then we don't have to type everything in again. So hit minus and hit enter, and there we go. There's our other answer. Now let's think about that for a minute. Which answer would actually be our answer? And yeah, we have to have x greater than 0 from our domain, so this second answer would be extraneous. So our only answer would be 29.72. The other one is extraneous. 29.72, and then the negative 2 point something would be extraneous. All right, good. Let's take a look at something a little bit more difficult. Okay, don't you love hearing solving more complex log equations? Like you needed that, right? Okay, but actually this one's not so bad. In fact, you've had a little bit of textbook work like this already. It's really just a matter of getting rid of the log by changing to exponential form and then going from there. But what we have is a log embedded inside another log. So to get at the ultimate x inside, we want to first start peeling it like an onion. We're going to get rid of the log base 2 on the outside here by going 2 to the on both sides. That gets rid of that one. So now we have log base x of 3x plus 4 equals 2, and we are going to get rid of the other log by going like this. Raise both sides again to whatever base was on the log. This time it was x. And now we have 3x plus 4 equals x squared. Oh, what do we have? X squared and x. We have a quadratic. So we want 0 on one side in order to factor this. But we want to keep x squared positive, okay? Even though it'd be easier to bring just one term to the left side, we want to keep x squared positive, so we're bringing 2 terms to the right-hand side. So we're going to subtract the 3x and subtract the 4 from both sides. Good. Okay, so why don't you guys go ahead and factor this and then see if you can determine which answer, maybe both work, sometimes they do, but which one is the answer, which one is extraneous. Okay, you guys keep going from there. So pause your video now, please. Okay, so let's talk about what our domain is restricted to in this situation. We have 3x plus 4 inside the log, so that has to be greater than 0. And if we solve that, we would get 3x greater than negative 4, x greater than negative 4/3, right? Okay, which negative 1 is actually bigger than that. However, we have an extra little complication. Notice x is the base on the log. Okay, you can't have a base also that's negative or 0. So because of that, we also have the restriction that x is greater than 0. Okay, so as a result, x equals 4 is an okay answer. X equals negative 1, not so much. Okay, so that one's extraneous. Okay, so a little tricky. You also have to check the base if x is in the base. All right, good job. Let's look at the next page. Okay, sample number 5, solve and verify. So solve the equation log of x squared minus 3 log x equals 10 by using laws of logarithms. All right, so you notice we have both base 10. That's a good thing. We have a log minus a log, but we can't combine that. That 3's in the way, so let's bring that back into the exponent. So we'd have log x squared minus log x cubed equals 10. Okay, that works. We could have also brought the 2 down front, and then we would add 2 log x minus 3 log x, which would be negative log x. That's another way to go. So there's more than one way to do this one. Okay, now that we are subtracting 2 logs, both base 10, we could write that as dividing within one logarithm using our quotient law. There we go. And then we want to get rid of our log, which is base 10. So we're going to raise both sides or change it to exponential form. And that would get rid of that log. So x squared over x cubed now equals, wow, big number, 10 to the 10. Okay, let's keep going with that. We'll multiply the x cubed over. We could, actually based on our domain up here, we know that x has to be greater than 0, right? So we could actually reduce the rational expression here because x can't equal 0 anyways, but whichever we do this, it doesn't matter. So we go 10 to the 10 and then times x cubed. Okay, we want to get everything on one side so that we can factor this. And you're probably wondering how to factor this. Well, we could take an x squared out. That's a common factor, and we'd have 10 to the 10 x minus 1. You'll notice I've avoided writing 10 to the 10 because that's not good. It's a huge number. So let's just keep it as an exponent. It's easier to deal with. Okay, now that it's factored, we branch each one off to equal 0. X squared equals 0, or x is equal to 0. This one, 10 to the 10 x minus 1 equals 0. And if we solve that, we would get, bring the 1 over, divide by 10 to the 10. So we'd get 1 over 10 to the 10. Or, if you bring that power up to the numerator, that would be 10 to the negative 10. Okay, now, is 10 to the negative 10 greater than 0? Yes, it is. Because think of it as 1 over 10 to the 10. It's close to 0, but it's not smaller than 0. So there we go, that's our answer. Okay, now, solve the equation in B. Okay, so this equation in B, if you look at it, we've got log x all in brackets squared. How is that different than what we had up here, where it was log of x squared? Well, what we had up here is the log of x squared. Here is the log of x, and then squared, which means it's actually this, log x times log x, whereas the other one was log of x times x inside the log. Okay, so that means that we can't actually solve it with logarithm laws. So what we're going to do is use this little method they're talking about here. We're going to replace log x with a new variable a. Okay, solve for a, yada yada, and then sub back in. So we're going to do that right here. So we have log x in brackets squared minus 3 log x equals 10. Okay, so we're going to replace log x with a, okay, and that's going to become a squared minus 3a equals 10. And you go, hey, that's a quadratic equation. Let's get everything on one side so we can factor that, right? Did you say those exact words? I bet you did. Okay, now we're going to factor that. So a and a times a is a squared. We have to multiply to negative 10, add to negative 3, so minus 5, positive 2. Now that it's factored and equal to 0, each factor using zero product law could be 0. So a would equal 5, and a is equal to negative 2. And there we go. Oh, we're not done. There was no a in our original equation. So now what we do is we replace a back again with log x. So log x equals each one of those. And now we have two new equations to solve. Yippee! So we get rid of the log by going 10 to the under both of these. Okay, and so that means our answers are going to be x to the 10, x equals 10 to the 5th, and x equals 10 to the negative 2. Okay, if we look back, our domain was x greater than 0 for both of those. So are both those answers greater than 0? This one definitely. Okay, 10 to the negative 2 is the same as 1 over 100. So yeah, that one's fine too. All right, good job. So let's look at example D. This is one of those errors thing. So I want you to pause your video and then take a look and see if you can find where this student made the error. Okay, so pause it now. Okay, so the error, I don't know if you guys realize this, what happened right on the first step from here to here. Actually, it would show up on the second step. So this is where the error happened. The person interpreted this as being this, right? So they scooped the log x out and put